Good morning, everyone. Welcome back to our chapter 4 of the Natural Language Processing course. And today's lecture will be about basic term extraction. And here is the outline of our lecture today. Firstly, we will review text pre-processing, which was already covered in the previous lecture. And next, we will see on term extractions, which covering on some important points. We have para-speech touching, or we call it in short, post-touching. And we will take a look on regular expressions, following by noun extractions. And lastly, we will see on the noun phrase extraction. However, we will cover it in the next chapters, as it will also include some other related important notes. So here is the text processing that we have seen in the previous lectures. We have 4 main processes. The first one is called sentence tokenization, which we get the input text and we separate those into sentences. And next, it is called word tokenization, where the input of this process is each sentence, and we obtain the word tokens, which represents each word of the sentence. And the third process is word stemming. We find the base form of the words, and last but not least, we have the stop word removal, which removes unimportant words, which is called stop words. And as the output of the text pre-processing, we obtain terms, or we call it features. So in this lecture, we are covering on para-speech touchings. So in this process, it will be taking part in the first 2 main process. We have sentence tokenization and next word tokenization. So after the word tokenizations, we'll have another process called post-touching here, which allows us to extract some words, some terms from the input sentence. So now we come to the para-speech touching. So what is para-speech touching? Or in short, we call it post-touching. It is a process of identifying para-speech in a sentence. It allows us to know whether a word appearing in the sentence it is verb, noun, adjective, or some other para-speech information. For example, we have this table. We have the word study. It is functioning as a verb, where the word student is functioning as a noun. So in the process of para-speech touching, we will see on the text which represents different para-speech. For example, in these tables, when we see NNP, it is represent a proper noun in the form of singular. And we have NN here. It is a noun which is in the singular form. And if we see NNS, it represents as the noun in the form of plural. And for verbs, we have many types here. It is based on the context that the word is used in the sentence, whether it's a base form, a past tense, gerund, or some other informations. And we also have some other para-speech. So next, we will take a look on the possible text available from NLTK. For example, as you can see from this table, we have the text. This is the description of the text, and we give an example in the third column here. For example, if you see JJ, it is representing as an adjective. So in adjective, it is also separate to the comparative or superlative as well. For example, we use JJS for representing the superlative forms. For example, we have the word biggest. It is used in the context of superlative, right? So to obtain these informations, the tag JJS is used. And we can see also other tags that are used to represent the para-speech in the sentence. And next, we will take a look on how to perform para-speech touching using an LTK library. So from here, you can include an LTK library. And next we have, for example, suppose that we have 3 sentences here. We store it as in a variable text. So in Python, to be able to write the information in multiple lines, we can use triple quotes here so that you can write whatever you want to type using new line. So next we have the sentence tokenization, which we saw in the previous lecture already. And next, for each sentence, we try to do the word tokenizations. So after the word tokenization, as we discussed earlier, we have the post-touching process, which allows us to do part-of-speech touching for a given word tokens of a particular sentence. So from here, as you can see, when we do post-touchings, the result obtaining from this function is a list of word pairs obtaining from the sentence. For example, as you can see in this rectangular box, we have for the sentence, the first sentence, I go to school, we have I here, it representing as a proper noun. And next we have the word go, which represent in the verb. And so on and so forth. We also have some other terms that appearing in this sentence, and it gives us the tags representing the part of speech for this word. So we already know what is NN, what is PPR, what is VBD, and some other informations that we already discussed in the previous slide. So next we will see how we can obtain terms from the input sentence. So from post-touchings, it allows us to obtain necessary information that we want to obtain from the tokenization process. So from here, suppose that we do post-touchings. As we can see from the output of the post-touching process, we obtain the list of word pairs from the sentence. It gives us the particular word and its part of speech. So from this, we can now create a function which allows us to extract those terms from the output of the post-touching. For example, in this function, we define a getNoun function, and the input of this sentence will be a tokens. And next, we can use loop for word post in tags, because the tag is an array of key value pair. So we can use this form of loop syntax for word post. So for here, which will give us the first key in the array, and next post it will be a value. So from here, we know for each element in the array, we get the word and part of speech. And next we can check whether this part of speech in which form that we want. In this case, we check it with the noun, right? So the noun can be singular or plural form. So in this function, you check if post in NN, comma, and NS, which is a noun in the singular form and plural form. So to obtain this, after we check condition, we append those words into the array called noun variables. So after using this function, you will obtain all related nouns from the input sentence. And similarly, if you want to also obtain some other tags, for example, adjective, verbs in gerund form, you can also do the same way, just replacing the array of the condition whether you want which tags that you really want from the sentence. Is it really easy, right? It's not much taking time to write the codes using Python here. And next we move on to regular expressions. And in regular expression, we can also use from an LTK libraries. But first of all, we will see the basic syntax that is already provided from Python built-in function. We call it regx here, or representing as a regular expression, or in short we call it RE. It is a sequence of characters that forms a search patterns. It allows us to check whether a given string it contains specific information. For example, you specify the rule how you can match, how you can search for a particular string. So from this library, we can import RE here. So from RE module, we can have many functions available. As you can see in this table, we have find all, search, split, and sub here. And there are some more functions that we can use. But specifically, we will use the function search and find all. So what does the function find all will do? It will return us a list containing all matches of our given rule. And for the search functions, it will return a match object. It is not a value, it is an object that is matched from the sentence. So you will see it in the next slide for the example. And in this slide, we give an example on how we can search the string to check if it starts with the word the and ends with the word span. So from here, to give a rule to the function, as you can see in the code here, we have a given text txt equal to the rain in Spain. So how we can write the rule in here? In the function search, you pass a rule, whatever you want to specify. So there are two arguments in here. The first one is the rule, and the next one is the given string. So in the rule, what do we need to do? We know that we want to check the word starts with the, right? So in regular expression, there are some necessary sequence, special character that we can use. For example, as you can see in the symbol in here, we have the upside down angle, which is used to specify that the word should be start with the here. And we have the star, which represent many occurrences. And we have the words, the special character $, which allow us to end the sentence with the preceding words. For example, the word span here. So in the middle of the sentence, it can be anything. As you can see in the input sentence text here, we have the rain in Spain. So if we match the sentence first, because we specify the rule that start with the and end with the word Spain. And now we will take a look on all the available special characters providing from regular expressions. For example, you have the set of character. You can use these brackets. It allows you to specify the set of character that you want it to match. For example, you can use this bracket and you put the rank of character. So it means that it will match any characters containing from A to M. So remember, this is only one character. And if you want to use special character, we need to start with this symbol, backslash. For example, to match the digit, any digit number, we use /t. Anyway, we will cover it in the next slide. What are the available special character that we can use? And next, we have the dot symbol here, which will match any characters except the new line. For example, you can see the word he.o here. That means it will match the word that start with he and end with o. And in the between here, it must has two characters. And you have the symbol, as we can see in the previous example. We have start with and end with. And if we use star, that means it will match any characters. It can be 0 or more occurrences. For example, as you can see in this example, AIX star, it will match any possible strings that containing AIX, and for the suffix, it can be anything because we use star, right? It can be empty or it can be many. And if we use plus, that means it must has at least one characters that appearing in that rules. And we have curly brace here, which allow us to specify the number of character that will be matched. For example, we have AL2 here, which allow us to know that this character should be appearing 2 times. And we have OR. We use the vertical bar, and if we want to group a specific rule together, we can use parentheses. So this table will show you the special sequence that allow you to match it faster than giving a manual rule like in the rank of number, in the rank of letters. For example, you can use slash capital A, which returns a match if the specified character at the beginning of the strings, right? So instead of using the symbol ankles upside down, you can use this slash A, which allow you to match in the beginning of the string. And for example, another example, slash D, little d here, which allow you to match whether the string contains digits. So the digits here can be in the rank from 0 to 9. So oppositely, if we use slash capital D, it will do the opposite way of matching. So it will match the string that does not contain the digits. And we also have white space characters and any word characters, so on and so forth in this table. And these are some examples that allow you to match some set of characters. We can take a look on the descriptions one by one here. And as you can see from the first example here, we have bracket and we have the rule A or N. So that means it will return a match first. One of the specified letter here must be present. So it can be either letter A or N. But if you use in the rank, we use A. In the next example here, we have the rank A to N. So that means any character in this rank from A to N, it will give you the matchings. Most importantly in here, we need to make sure that our character given here, it is in the correct form, for example, in lowercase or uppercase. And if you want to match 2 digits, for example, in the example 0 to 5 and 0 to 9 rank, it will allow you to return the match for any 2 digits numbers. From 0 to 5, the first digit must be in between 0 to 5, and the second digit must be 0 to 9. So for example, we have 0, 0 and 5, 9. It gives us the matching. However, if we use 6, 7, it will not match because the first number is 6. It is out of the rank from our specified rule, which is 0 to 5. So similarly, we can also provide the rank of character as well. So next, we will take a look on how we can write regular expressions. So in the first exercise here, we write a regular expression to detect 5 digits number. So how we can do that in Python? So we import the built-in library OE here. Suppose that we have the data to check. We have 4 data, the list of string here in the data variable. And for each of the data in these variables, we find the regular expression using final function. So in final function in here, you specify the rank of number, right? So the number can be from 0 to 9. And we have the number occurrence, which is 5. We put in the curly brace. So it means that we will allow us to match the rank of numbers from 0 to 9. And there are 5 of them. So that means 5 digits. So what is the output of this sample code? it will give you the matchings. So if there is no matching, you will obtain an empty array. But if it is matched, you will give an array containing the matching value. As you can see in the data, sample data, we have the first element 25631. It is 5 digits, right? So as the result, we can get it in an array of the result. And the next element is 298. It is 3 digits, so it does not provide us any matching. So the output of the function is empty array. And for the third element, it is 5 characters, right? However, it containing some letters. So as our rule, we define the number ranging from 0 to 9. So from these, it does not match the string. Last but not least, we have another 5 digit numbers. So we also got this matching. So as a result, we obtain 2 matchings from this input data. So from these, we cannot use the function search from the regular expression. So the result from here is a returning object. It's not an absolute value. To obtain the match value, you need to do some process in order to extract those information. So I recommend that you can use the function final as we see in the first example here. So next we will see on the second exercise how we can write a regular expression to validate a Gmail address. So remember that we need to define some rules. So our rule here is that the email cannot start with a number. So here are some examples of the valid and invalid email address. For the valid, we have test@gmail.com, test_data@gmail.com, and invalid, the first one is starting with a number, and the second one is not a Gmail address, right? It is @yahoo.com, so it's not considered in our exercise here. So what rule can be made in here? We have a test of list of email address, and then we use the final function. So in final function, we need to specify the rule that we want to allow it to match. So it starts with letter, right? Not a number. So we provide the rank of either it is a lowercase or uppercase or underscore, and it does not contain white space. So you have /s here, and plus here means that at least one of the character, right? As we remember from the previous special character set. And next, it can contain any letters. And after the letter here, it must be an @gmail.com. So for the dot symbol, if we use only dot, that means it match any character, right? So but in our case, this is the pattern that we want it to match, which is .com. So you need to use the / symbol here. So the output of this matching is given from this example, as you can see. But remember that this rule is not perfectly match the email address. For examples, we have the some other input email address. It may not detect all of them, so we can track down all of this input as well. So next we will see on the homeworks, and I hope you will do it at home to understand more on this lecture. The first exercise is to write the Python programs to extract the information from the input sentence. So the information here, we want adjectives, we want verb and nouns from the text. So how we can do that? So you can follow the hint here. First, you can do pause touching, and you get an array, right? So you loop this array, and next we can find the necessary related informations like adjective, verbs and nouns. So we consider that when you use verb, it can be appearing in any forms, whether it's a base form, a past tense, a gerund, or some other verb form, for example, when it's used with surplus and singular. So As you can see in the hint here, I provide the list of verbs that should be possible to extract from the input sentence. And we have the noun. It can be a singular or plural noun. And next, we have some more exercise on writing irregular expressions. The first one is you write a regular expression that detect words that start with CH and end with E. So to start with CH, you may use the upside down angle, and end with E, you can use the dollar symbol. So we notice that we also consider on case sensitive. So if the word CH it's starting with the word CH, but it is in uppercase, it will does not match. And next exercise is you write a regular expression to detect a binary number. So we know that binary number can be only in between the rank 0 and 1. It cannot be any other number. And last but not least, write a regular expression to detect a hexadecimal number. So I think you already learned on what is binary, decimal number and hexadecimal numbers. So just give a rules that match these regular expression for finding those number. Okay, that's all for our lecture today. I hope to see you soon in the next lectures.